Yeah, Dennis. Okay, good. So I believe that everyone is aware, right, that your practical has been cancelled. So I think your final examination, you only sit for the paper 1 and 2. Okay, the third practical has been cancelled. So your weightage will be more to paper 1 and paper 2 now. So you have to do good. You have to do your best. Try to score as much as you can in the paper 1 and paper 2. Okay, any questions about that? Do you have any questions about that practical? No, you received the announcement today, right? Today, okay. So, any questions about it? No. No. Okay, so let's continue with our lesson today. Okay, so we are halfway of doing the temperature. We will try to finish that topic today. Okay, so temperature, halfway the topic. So we done about thermal equilibrium. What is meant by thermal equilibrium? We talk about the temperature scale. What are the 3 things we have to do to get your temperature scale? Then third, we talk about the practical thermometers, the 4 type of thermometers which is currently available, and plus and minus. Okay. So first we talk about thermal equilibrium. Then we talk about the temperature scale. We need to get the thermometric property that varies monotonically with temperature to be identified and to be used. 2 fixed point, melting point and boiling point of melting point of ice and boiling point of water is used. The numerical scale will be developed. Okay. The thermometric property to be used must be a physical quantity that is varies monotonically. Monotonic increasing or monotonic decreasing with temperature to be used. Okay, yeah, so these are the 4 type of thermometer we done, plus and minus. Liquid glass thermometer, very direct reading, portable, but problem is not least accurate. Constant volume gas thermometer, very accurate, but very bulky, so used for city temperature. Okay. And the third, resistance thermometer, it takes time to achieve thermal equilibrium, but very accurate, quite accurate, used for melting and boiling point. And finally, thermocouple. Thermocouple is used for varying temperature. With 30 seconds, you want to record down a temperature every 30 seconds. Thermocouple is the best because it has a very low specific heat capacity and very fast react. So thermocouple used for varying temperature. Thermocouple varying temperature. Resistance is for melting, boiling point. Constant volume gas thermometer for city temperature. Mercury in glass for clinical purpose. Okay, so we're done here. Then with this, the equation. The equation is only correct by we doing assumption that this equation is the equation we use to calculate the temperature between 0 to 100. So any temperature we obtain, we indirectly we are assuming that it changed linearly. Only linear this formula we assume like that the thermometric property changes linearly. Okay, so today we're going to talk about from here disadvantages. Okay, for that we go to the PowerPoint. Okay, guys, can you hear me, right? Because very silent, nobody replying.
Yeah.
Anybody? Yeah. Okay.
Yes.
Okay. So we're done with this comparison. Yeah. So we start discussing from here. The shortcoming of centigrade scale. Okay. The shortcoming of the thermometers last is actually using centigrade scale. The problem is the only problem arises with the for thermometers is different types of thermometer will give different reading. Reading may be different slightly. So this disagreement arises because the thermometric property varies linearly with temperature may not be true. Yeah, I think I told you this indirectly. Okay, mercury in glass may be from 0 and 100, like for example, whiteboard. Okay. Okay, so if you put a mercury in the solution, and we only get two fixed points. We get at 0, L0, and at 100, L100. Okay, so we make it as a straight line, but in reality, we get all the other readings. Like for example, theta, when this L theta was obtained, we are assuming this is linear, but indirectly, actually, it could be a little curve. It could be a little curve. So this is the assumption we did. We assume that thermometric property change linearly with temperature. May not be true. Okay, that's why different thermometer give a different reading. Okay, so very important what do you call explanation they will ask in exam. Why different thermometers give different reading for the same substance, for same liquid maybe. Because this is the reason you have said thermometric property may not vary linearly with temperature. Okay, so all the thermometers only agree to the two fixed points. Okay, so the centigrade scale got one downfall because the temperature changed linearly with the thermometric property changed linearly with temperature may not be correct. Okay, it might be slightly curved. So do we have any other scale to depend on? They say there is another scale which can give you a temperature quite accurately. Only the absolute thermodynamic scale is independent of the property of the thermodynamic substance. Now our discussion is going to talk about this scale, another scale. The first scale, all the thermometers use centigrade scale. Centigrade scale dividing the 0 degree Celsius to 100 degree Celsius to 100 division, centigrade scale. So centigrade scale got downfall because it might not, the thermometric property might not change linearly with temperature. So now we have another scale called absolute thermodynamic scale. Okay, what is this scale about? That's our discussion today. Okay. Okay, so a lot of words. We just focus to the highlighted wording, the green color. This is called thermodynamic temperature scale. Okay, thermodynamic temperature scale is now accepted as a fundamental measure of temperature. This scale measures temperature in terms of Kelvin. Okay, the earlier scale measures in terms of degree Celsius. Okay, degree Celsius. The thermodynamic scale measures in terms of Kelvin. It also known as absolute temperature scale. You can call it as a thermodynamic temperature scale, or you can call it as an absolute temperature scale. Got two names. Okay, so it has only one. There are one fixed point for absolute temperature scale, absolute zero Kelvin. 0 Kelvin is one fixed point for this scale. Okay. Actually, there are two fixed points in this scale. One of them is absolute zero. I believe in your O levels you learn about absolute zero. 0 Kelvin. You know what is 0 Kelvin, right? What is 0 Kelvin? What is 0 Kelvin? You call it absolute zero. What is so special about absolute zero? Absolute zero is the temperature at which the particle constituents of the matter are at rest. it has a zero kinetic energy. Okay, so absolute zero is a temperature where all the particles of the substance attain zero kinetic energy. We can say it's absolute zero. Okay, this is also quite famous in exam. They'll ask, what is meant by absolute zero? So absolute zero is 0 Kelvin, where the particle attain zero kinetic energy. Okay, so that's absolute zero. Okay, so absolute zero is one of the fixed point in the thermodynamic scale. Okay, 0 Kelvin we know is negative 273.15 degrees Celsius now, equal. Okay. Okay, now the thermometric property, it's not based on thermometric. Yeah, the thermodynamic scale, this new scale, is not based on thermometric property. It's not based on length. It's not based on what do you call voltage. Not based on resistance. This measurement is based on natural property of the gases. It's based on ideal gas law. Okay, thermometric property. This thermodynamic temperature scale is based on what? Based on ideal gas law. Gas law. You learn about gas law, right? Recall back. You learn 3 gas laws: Boyle's law, Charles' law. Do you remember? So, okay, go back to the whiteboard. Okay, if you have a gas, trapped in a closed container. Okay, the gas contains 3 parameters: pressure, volume, and temperature. How these 3 quantities is linked? Are they proportional or inversely proportional? This is leads to the gas laws, right? Gas law. The first law is like how pressure and volume related. I believe you learned this before. Okay, but today's lesson we are not really discussing about the pressure and volume. We discuss how pressure and the temperature of the gas related. Okay, because we want to measure temperature. Okay, so how, if you have a gas inside, you increase the temperature. When you rise the temperature, what happened to the pressure inside the gas? The pressure, the particle going to collide to the wall more frequently, so the pressure rises. So what is the gas law? How pressure and temperature related? Pressure is found to be proportional to temperature. Greater the temperature, greater the pressure of the gas. This is one of the gas law we're going to use to calculate the temperature. The thermodynamic scale based on this law. Pressure of a gas is directly proportional to the temperature. This is called ideal gas law. To be more accurate, we call it ideal gas law. Okay. Any question about this? Ideal gas law. Please recall back. Pressure of the gas is directly proportional to the temperature. It's the thermodynamic temperature. Okay, so we go to the 5th one. The thermodynamic temperature scale is based on pressure is what? Pressure is directly proportional to the thermodynamic temperature in Kelvin. Okay, this is one of the gas law. Okay, gas law. So this temperature we can call it as the thermodynamic temperature, or you can call it as an absolute temperature. Okay, don't just say pressure is directly proportional to the temperature. You have to say pressure directly proportional to the temperature in thermodynamic scale, or absolute in thermodynamic temperature or absolute temperature. Okay, the T. Okay, so yeah, so this is the new scale introduced. Okay, use the gas law. The lower fixed point is the absolute zero, and you have another fixed point. Upper fixed point is called triple point of a substance. Triple point. Here we focus to triple point of water. Okay. You see, the centigrade scale got 2 fixed point. What is that? A boiling, melting point of ice, boiling point of water, right? This thermodynamic scale got 2 fixed point also. The lower fixed point is absolute zero, 0 Kelvin, and upper fixed point is called triple point of water, triple point of pure water. A lower fixed point, maybe you are quite familiar. 0 Kelvin, right? You learn in your O levels, okay? When the kinetic energy of the particle becomes 0 Kelvin, the lower fixed point. The upper fixed point is maybe something new for you, never learned before. It's the triple point of water. Triple point of water. Okay, what is triple point of water? Okay, triple point of water. So the triple point of substance, but we go for water. Triple point of water is the temperature and pressure at which the three phases, solid, liquid, vapor of the substance coexist in thermal equilibrium. That called triple point of water. Okay, you might not thought about this before. What? Solid, liquid, vapor. The water, the H2O, in form of solid, ice, liquid, water, vapor, steam. The ice, water, and steam coexist together at a one single temperature. It's called triple point of water. Okay, you might think it sounds funny. How can ice, water, and steam can coexist together? Can it coexist together? We know that at 0 degrees Celsius, the ice might be coexist together with the liquid water. So the solid can be coexist together with the liquid at 0 degrees Celsius. Then we know at 100 degrees Celsius, when we heat up, the liquid, the boiling water can coexist together with steam, vapor. Okay, that means liquid can coexist together with gas at 100 degrees Celsius. 0 degrees Celsius, solid and liquid. 100 degrees Celsius, liquid and gas. This is what you learn in O levels, right? Okay. But now, triple point of water is what? Triple point of water is one particular temperature where the solid, liquid, and gas coexist together. That means at the bottom, you have ice is floating, liquid is liquid at the bottom, and at the same time, steam also is like appearing. Okay, you have gas. The three phase coexist together. This is called triple point of water. But first of all, how can these three can coexist together? We know it's 0 to 100. Okay, so they say it can. How it can? They say how we can coexist together. They say you lower the atmospheric pressure. You lower the atmospheric pressure, these three phases can coexist. Something new. You reduce the atmospheric pressure, the three phases can coexist. Okay, how these three phases can coexist? I show you one graph. Okay, so I haven't talked about the last line yet. Okay, I show you this graph. Okay, so this is the graph, pressure versus temperature. Pressure versus temperature. This graph for H2O, for water, for water. Okay, you see, when the pressure is very high, and the temperature is very low, the substance most likely will be in form of solid, right? High pressure. Substance you apply with high pressure and at a low temperature, it most likely will be in form of solid, right? It will be very solid. Okay. When the temperature rises, it might fall into liquid, and the temperature get further, it definitely at low pressure and high temperature, most probably it will be in gas. Okay. So far in your O levels, our exposure is only up to 1 atm. 1 atm, and that pressure is 1 atm. For water, we found that the border of solid and liquid crosses at 0 degrees Celsius. Okay, at 1 atmosphere. Then you go further and increase the temperature at 0 degrees Celsius. The liquid and gas phase border crosses at 100 degrees Celsius. So you see liquid and gas. Okay, so you only can see the border between solid and liquid at 0 and liquid and gas at 100. But you can meet all these three borders, meet up at one single point at A. This is the point A. Okay. This point called triple point. This is called triple point of, because this is water, so we call it triple point of water, the point A. The point A. To achieve point A, you have to reduce the pressure. So 1 atm, you have to reduce the pressure. That means what happened? You want to see the solid liquid gas in your room to be, the water to be coexist. The surrounding pressure need to be reduced to a low pressure until we go to this point. At this point, the water found to be coexist together in form of solid, liquid, and gas. And this happens at what temperature? Through experiment, they found that the triple point of water is found at 0.01 degrees Celsius at atmosphere at a pressure of 0.00603 atm. Okay, so this is called triple point of water. Okay, the 0.01 degrees Celsius, if I change to Kelvin, it's going to become 273.16 Kelvin. Yeah. Okay, so this is second fixed point. Okay, what is that? Triple point of water, 273.16 Kelvin is the triple point of water. Is the upper fixed point for this scale. Okay, lower fixed point is absolute zero. You well versed about that. Okay, 0 Kelvin, the kinetic energy of the particle becomes 0. The second fixed point is something new. So first time you come across triple point of water. Triple point of water, which is 0.01 degrees Celsius or 273.16 Kelvin. Okay, it happens at a lower atmospheric pressure, 0.00603 atm. Okay, so this is so far describing about thermodynamic temperature scale. Okay, why are we learning this scale? This scale found to be more better scale compared to centigrade scale, which used up by all the thermometers. Centigrade scale got one downfall. What is the downfall? The thermometric property changed linearly with temperature may not be true. Okay, therefore the temperature reading might be different, okay, than actual. So this factor is overcome by this scale, thermodynamic scale. In exam, they will ask, what's the difference between centigrade scale and thermodynamic scale? Centigrade scale works based on thermometric property. Thermodynamic scale works based on ideal gas law, where pressure is directly proportional to thermodynamic temperature. Okay. Centigrade scale got two fixed point, melting point and boiling point for water. Thermodynamic scale also got two fixed point. The lower fixed point is absolute zero, and upper fixed point is triple point of water. So in exam, they'll ask, what is meant by triple point of water? The triple point of water is the temperature where the water coexists in three phases, form of solid, liquid, and vapor. The solid, liquid, and vapor coexist together at that temperature in thermal equilibrium. It's called triple point of water. Okay. Okay. So far, any questions? Something new, eh? So far, no questions, eh? Okay. Okay, why pressure proportional to temperature? Why this scale is found to be more better than centigrade scale? Okay, let's discuss about that. Okay, just now the centigrade scale, we found that thermometric property L and theta, it might be curve. Okay, it might be a curve, but for thermodynamic scale, we done this experiment in O levels. You have discussed about the experiment in O levels, right? Like pressure versus temperature for a gas. If you have a gas, the gas must be an ideal gas actually. It has to be an ideal gas. Okay. when the temperature is rise, how the pressure change. You have come across this graph, right? It cuts at what? It cuts at negative 273.15. Okay, okay. The gas changes. This graph is found to be perfectly a straight line. We know that this is a straight line, no doubt about that. Okay, the pressure of the gas change linearly with temperature. This is what we want. Okay, so we are very sure that the ideal gas law changed linearly with temperature for sure. But for centigrade scale, all the thermometric property change a little curvature, so not good. So thermodynamic scale is, we know definitely is linear. Okay, but the type of gas need to be used must be an ideal gas. Okay, this is where the problem starts. The type of gas you must use is an ideal gas. Okay, do you heard of ideal gas? Do you heard of ideal gas? Anybody? What is meant by ideal gas? Actually, next topic we're going to discuss about ideal gas. But in O level, do you heard of ideal gas? Anyone? Riyad, do you heard of ideal gas?
We learn in chemistry for A levels, but I don't know in IGCC.
Okay, so you already learned in chemistry, right? Ideal gas. So what is ideal gas in chemistry?
It's when gas is when volume is negligible and temperature is negligible, right?
Temperature negligible, huh? Okay. You have ideal gas and real gas, right? Real gas. Real gas is the gas which we are exposed to the surrounding. Real gas, the actual gas. Okay. Ideal gas is ideal. Ideal. You see the word ideal. Actually, very perfect gas is ideal gas. Ideal gas is a type of gas that obeys gas laws at any pressure, temperature, and volume. That's ideal gas. Okay, what is ideal gas? The pressure proportional to temperature. Okay, the pressure proportional to temperature. This graph, right, straight line, only can be done by an ideal gas. Okay, ideal gas is a type of gas where doesn't experience, don't have what? Ideal gas and real gas got one main difference. Ideal gas, real gas got that force, but ideal gas don't have that force. What force? The intermolecular force. The intermolecular force. Ideal gas don't experience intermolecular force. The force between two particles, the air particles, there is no intermolecular force. Okay, they don't have intermolecular force. There are a lot of assumptions. Okay, one of the assumptions is, the main assumption is the ideal gas don't have intermolecular force. Okay, so but real gas, the gas surrounding you now, you are breathing, there is oxygen, of course nitrogen surrounding you. The oxygen particles between them surrounding you, now they have intermolecular force. It's a real gas. Okay, real gas cannot be used to measure the temperature here. Only ideal gas can be used to measure the temperature. Okay, so that's the problem in this scale. How to create ideal gas? How to get ideal gas? Anybody? The only way is we need to change this real gas which we have to an ideal gas. How do we convert real gas to ideal gas? Real gas can act ideally, that means it follow this pressure proportional to temperature at high pressure or at low pressure. At high pressure or low pressure, real gas will act as an ideal gas.
Low pressure and high temperature.
Very good. Low pressure and high temperature. Yeah. So low pressure and high temperature, right? So recall back. The real gas act ideally at low pressure. Low pressure means the atoms are far apart. When the atoms, the particles in the gas, if it's very far apart, they don't really experience the intermolecular force. So they will act ideally, ideal gas at low pressure. At high temperature, the particle will be further apart. When the particle is further apart, then it won't experience the intermolecular force. Then it will act ideally. Okay, yeah. So that is thermodynamic scale. Thermodynamic scale based on ideal gas law. Ideal gas law, which is pressure proportional to temperature. We know it's going to be a straight line, but the gas must be an ideal gas. But now we got problem. We only have real gas. So how to make real gas become ideally? Either make it low pressure or high temperature. But we use the first one. We use low pressure. So we use low pressure. That means what we do? We take a gas for isolated system, a gas contains a gas, and this gas we make it so that this gas has a very low pressure at room temperature, very low pressure at room temperature. How to make it low pressure at room temperature? So we try to have how to make low pressure at room temperature is we reduce the mass of the gas trapped inside this container. We use less mass of the gas. Okay, we use less mass of the gas. You know chemistry. You learn the number of mole, right? The mole. We use very little mole here. We take a container, maybe about let's say 1 meter cube of container, but the amount of gas we trapped inside is the lowest mole possible. Okay, instead you use 1 mole, you use maybe 0.001 mole of gas trapped inside. The particle content is very little, so the particle going to be really further apart. So what happened? The pressure going to be very low. Then this particle, this gas can act as ideal gas. Okay. So the type of gas we're going to use must be an ideal gas. How to create ideal gas from the real gas is pack the gas in a container with very little mass. The amount of mass of the gas to be contained inside is very little. Okay, so that very little mass will have a little particle. The particle going to be really further apart, so they never experience the intermolecular force. They going to act as a ideal gas. Then if they get ideal gas, then it's going to follow pressure directly proportional to temperature going to be really correct. Okay, so you heat the gas at the theta 1, it gives you a certain pressure P1. When you heat the gas for theta 2, the pressure become P2. Then we can conclude P is proportional to temperature. So P1 proportional to theta 1, P2 proportional to theta 2. So for a different pressure, we can get the temperature because the gas going to follow this pressure proportional to temperature. Okay, I think I told you a very long story. So which part you don't understand? What I'm trying to tell you here is, I'm talking about more than 10 minutes here. What I want you to understand is the thermodynamic scale is better than centigrade scale. Why it's better than centigrade scale? Because you use ideal gas law, which is perfectly straight line, linearly change. The pressure change linearly with temperature. But now we got a problem. No such thing as ideal gas in this world. You only have real gas. So how do you change real gas become ideally? Recall back what you learned in O levels. Real gas only can act ideally when it never experience intermolecular force. How make the real gas don't experience intermolecular force? It happens when the particles are further apart. When the particle become further apart at low pressure and high temperature. So what we do? We create a system of gas which has a very low pressure. How to make low pressure? The mass of the gas we used inside, we use a very little mass. Okay, so that the amount of particle inside is very small, not much of particles, so that they are really further apart. So very low pressure, so they can become ideal gas. Okay, so this gas is used to measure the pressure. So this gas, which is at a very low pressure, this gas we can use it to measure the temperature. Let's say you want to measure the temperature of the certain water. This container, the gas we place inside. Okay, we measure the pressure of this gas. We measure the pressure of this gas by using, of course, a manometer. Okay, for this temperature. Then we put that that gas inside triple point of water, maybe we find the new pressure. I mean, we follow this formula: pressure proportional to temperature. P1 proportional to theta 1, P2 proportional to theta 2. So P1 over P2 equals to theta 1 over theta 2. So we can find maybe the theta 2. Okay, this is the process. Any questions, guys, so far? No questions, huh? Okay. Go back. So this is the triple point water. Okay, lower and upper fixed point. The temperature scale is based on fixed points. The fixed point is the single temperature at which the particular physical event is sure to be happen. Okay, we have ice point, steam point used for centigrade scale, but for thermodynamic scale we use triple point of water. Triple point of water. Okay, triple point of water. So triple point of water only happens for sure. The water going to coexist together at these three phases at 0.01 degrees Celsius for sure. Okay. Let me teach you now how you're going to use thermodynamic scale to calculate the temperature. Okay, let's say you go to clinic. Okay, the doctor want to measure your temperature, body temperature, and he want to use thermodynamic scale. Okay, you want to use thermodynamic scale. Okay, you don't want to use centigrade scale. Centigrade scale is the thermometer, just the thermometer. So you want to use thermodynamic scale to measure your temperature. So what you should do? Okay, so first what you do, there is one cell, something like shape like this, and this called triple point cell. Triple point cell. Okay, triple point cell. Okay, triple point cell. You're not seen in your school. You might see one in universities. If you go to university physics department, you can see triple point cell. Triple point cell is a cell which is a closed system where the H2O, the water, coexists in three phases. Okay, at the bottom you have ice, then you have liquid, and at the top you have the vapor. All three are coexist together. That means this triple point cell is the temperature of this triple point cell for sure is 0.01 degree Celsius for sure, or is 273.16 Kelvin. Okay, this triple point cell. Okay, so if the doctor want to use thermodynamic scale to measure your temperature, what you have to do is, okay, first you have to put the gas, the ideal gas into this triple point cell first. The ideal gas they use, of course, the constant volume gas thermometer. You know, the constant volume gas thermometer. The constant volume gas thermometer is used, but the amount of gas inside here will be very small mass, very little mass, so that it's an ideal gas. So the constant volume gas thermometer will be placed in the triple point of cell first. Okay, let's say that you are the patient, you are standing there, you wait for a while. Okay, the doctor will place here first, a triple point of cell. So the pressure going to change. You get pressure P1, let's say P1. Okay, P1. So you get P1 for what temperature? 273.16 Kelvin. Okay. Then what the doctor should do? He must ask you to achieve thermal equilibrium with this gas. That means maybe what you can do is you have to hug this flask or what. Okay, you have to do a thermal contact with this gas. So your temperature, body temperature, let's say is theta. The new pressure will be indicated by this ideal gas. Okay, it's P2. Okay, your body temperature is theta, is P2. Okay, that's all. Okay, this might happen for maybe 3 minutes or 4 minutes. Then after that, the doctor want to measure the theta. So how are you going to measure the theta? He used thermodynamic scale. Thermodynamic scale based on what law? Based on ideal gas law. Based on ideal gas law, pressure of the gas directly proportional to temperature. So the first reading he got, you know, the P1 is directly proportional to 273.16 Kelvin for sure. because it's a triple point of water. Then the the patient produce a pressure of P2 at his own body temperature theta 2. Okay, that's all you need. The first two data. So you can find the theta 2. So theta 2 ratio, what do you get? Theta 2 will be P2 over P1 times 273.16 Kelvin. Okay, so whatever answer you get, this is the body temperature of the patient. Okay, this is how thermodynamic scale will be used compared to centigrade scale. Centigrade scale straight, you thermal contact with the thermometer, whatever reading you got, that's your temperature reading. Okay, this centigrade scale got problem because you never change linearly with temperature. It's little curve, not that accurate. But thermodynamic scale very accurate. But do you think the doctor going to use this thermodynamic scale technique? It's not, right, because you need to have a triple point cell. Before you take your temperature, you have to put that gas into the triple point cell first, wait for a while, thermal equilibrium achieved, then he asks you to hug so that you achieve the thermal equilibrium for a new pressure, then he will calculate. So it's tedious, but see to be very accurate. Okay, so any questions, guys, so far? Thermodynamic scale and centigrade scale. So do you understand the flow of thermodynamic scale? So hope you understand. Okay. So the final conclusion. The centigrade scale use this formula. You need two fixed point actually. The melting point, boiling point, and the melting point of water. Then only you can find the theta. Okay. But now in thermodynamic scale, we only need one fixed point to calculate. Although it has two fixed points, we only use one fixed point data. You see, 273.16. This is the PV value. Actually, the volume is cancelled. Volume is cancelled because we use the constant volume gas. The volume of the gas is we fix. We never change the volume. So this formula can be changed to P theta over PTR times 273.16. This is the temperature theta. Okay, now you might think, what is this PTR all? Okay, PTR is actually the earlier, the P1, right? The P1 is PTR, pressure at the triple point of water. So P1 is the PTR. PTR, the pressure at triple point of water, proportional to 273.16 Kelvin. P2 is like P theta, P theta. Okay, so I write this equation: P theta over PTR times 273.16 Kelvin give you a theta 2. So what? P theta over PTR times 273.16 is your theta 2. Okay, so that's the formula here. P theta over PTR. We can cancel. Okay, so these are the differences. So centigrade scale got two fixed point. Thermodynamic scale, only one fixed point is required to calculate the temperature. Okay, centigrade scale based on thermometric property. Thermodynamic scale based on what? Based on ideal gas law. Pressure directly proportional to thermodynamic temperature. So yeah, so that's the two scales. Okay. Okay, so let's make use of the thermodynamic scale now. Okay, so what do you have to do? When the doctor want to measure the temperature of a body, first you need to find the P, pressure at triple point first, proportional to 273.16. Then you have to find the pressure at that temperature, which is proportional to that temperature. Then the theta found to be what? P theta over PTR times 273.16. Okay, this is the formula to calculate your temperature based on thermodynamic scale. Okay, use this, read the question, look at the solution. 1 minute for you. try to understand the working and the question and the solution. At the triple point of water, the pressure of fixed mass of gas is 2500 Pascal. So this is what? This is your PTR, pressure at triple point of water. So this is your PTR, pressure at triple point of water. The temperature is changed to T while the volume of the gas is kept constant and the pressure is increased to 5000 Pascal. So for a temperature T, for a new temperature, the pressure is 5000 Pascal, new pressure. So find the temperature T. So you write the proportionality, and P is TR is proportional to 273.16. In this case, PTR is how much? 2500 proportional to 273.16 Kelvin. Okay. Then 5000 Pascal is proportional to the new temperature T. So find the T. So proportional, right? Proportional. So T is equal to what? Rearrange, right? So 5000 over 2500 times 273.16 Kelvin. That's the working of A, right? That's the working of A, right? See, 5000 over 2500, 273. The temperature is 546.32 Kelvin. Okay. So proportional. Okay. Express the temperature in degrees Celsius. That's no problem. Just minus with 273.15. You get in degrees Celsius. Don't go 273 only. A levels 273.15. 273.17 degrees Celsius. Okay. So see what is the advantage of making this determination at such a low pressure. Why you take the temperature reading at a very low pressure. So as I told you, only at low pressure the T approaches the ideal gas law. The real gas become ideal gas law. The T approaches the ideal gas temperature. Okay, or you can say the real gas will become ideally. So therefore, you're going to go follow the gas laws correctly. Okay, any questions, guys, so far? No questions, Okay, so that's all. This is measuring. This is the constant volume gas thermometer. Okay, this is the gas trapped inside. The same thermometer will be used for thermodynamic scale, but the amount of gas kept inside here will be very low in mass, so that it become ideal gas. Okay. So yeah, the thermodynamic temperature. That's all. It's all about this topic. Okay. So we learn about absolute thermodynamic scale. The reason disadvantage of centigrade scale. Okay. So absolute thermodynamic scale is introduced. PV proportional to T. Okay. Got lower point, upper point, absolute zero, and triple point of water. What is triple point of water? The water coexists in three phases at that temperature. It happens at 273.16 Kelvin. Okay. So this is the graph. Kelvin, and finally the differences. Centigrade scale based on thermometric property, thermodynamic scale based on ideal gas law. Centigrade scale to measure the temperature, you need two fixed points. Thermodynamic scale, only one fixed point is required. Triple point of water. These are the two formulas necessary to calculate the temperature. Okay. Okay, so this topic is not much of a question. Topic 3, then after this we're going to talk about ideal gas. Topic 4, 3, 4, 5 will be together, will give you 2 questions normally. Normally topic 3 will be together with topic 5. So we wait for topic 5 after discussion, then only we can discuss questions, because it always will be together with the topic 5. Okay, so this is, so only this we can't do some much questions. We need topic 5 together. So after we finish topic 5, we will discuss the questions. Okay, but in between we go for topic 4, idle gas also. Any questions, guys? So no questions. Okay, so I stop here today. So we're done with this topic. Temperature. Temperature. Thermal equilibrium scale, practical thermometers. A new scale introduced, thermodynamic scale, which is use ideal gas law to measure temperature, found to be more accurate than centigrade scale. Okay. Yes, so see you tomorrow. Tomorrow we will start with the topic 4. Okay. Next week, Wednesday, as usual, because no practical, we'll be discussing your trial papers. And Friday, I'll be giving you a test. Next week, Friday. Next week, Friday, I'll give a test. Just objective, paper 1, 1 to 4, your AS, 1 to 40. Okay. Any questions? Okay, so I stop here. So see you tomorrow. Thanks.